9.3. We're on page 459, example 1. Determine the roots of the rational equation. So this is the rational equation here, and we want to find the roots. What does that mean, roots? X-intercepts, zeros, roots. Those are all the same thing. Okay, so basically all we're going to do is solve this equation so we can see what x equals. Okay, so the easiest way to deal with when you have something in the top and the bottom is multiply it all in the top to get rid of it. Okay, so we'll multiply this piece by x plus 2, this piece by x plus 2, this piece by x plus 2, and the 0 by x plus 2. Okay, so when I'm multiplying this x to this x plus 2, it's going to be x multiplied by x plus 2, and I can multiply him in afterwards. This guy has an x plus 2 in the bottom already, so they're going to cross off, so you'll just be left with a 6 there, and then we'll have a minus 5 multiplying to an x plus 2. And 0 times x plus 2 is just 0. Okay, so now we have a simpler equation because there's no denominator, so we will just distribute in. So x times x is x squared, x times 2 is 2x, and we have plus 6, and then we distribute the minus 5 in, so minus 5 times x is minus 5x, and a minus 5 times 2 is minus 10 equals 0. Okay, we will combine like terms. Okay, so this guy and this guy, this guy and this guy. Okay, so we'll have x squared, and then 2x minus 5x is a negative 3x, and then 6 minus 10 is a minus 4. Okay, it should be easy to find the x-intercepts now, or the roots, what they're calling them, because now we just factor this. So we need something that multiplies to minus 4, but adds to minus 3. Okay, so minus 4 and x plus 1. So our x's are actually 4 and minus 1, because it's the opposites of in the bracket. Okay, and all we have to do is make sure those are both solutions now. So we could plug them both into this equation and make sure that it equals out, like you'd get 0 on both sides, it would work out. Or what you can do is you can check the only non-permissible value in this first one would have been what? In this original would have been minus 2, right? Were any of these answers minus 2? No, so then we should be good. These should be solutions because they're allowed. They're not a non-permissible value. Okay, so for B it says if you were going to graph it, so we would just enter that on the graphing calculator. I don't know if the picture will show up anywhere here. Nope. I'll see if it shows up here. There's the picture. Okay, so if we were going to graph it, it would look like this. Okay, and it would say the x-intercepts we would look are there and there. Okay, so the question asked, what is the connection between the roots of the equation and the x-intercepts? Those are the same thing. So if you graphed it and you saw where it crossed on the x-axis, it should be crossing where we solved it algebraically. Okay, because roots and x-intercepts are the same thing. Example 2 is page 460. It says solve this equation graphically, express your answer to the nearest hundredth. Okay, so we could enter this on the graphing calculator. If it says graphically, enter it on the graphing calculator. And we would find where the x-intercepts are, and they would be at, in the book it says negative 0.43 and 3.1. And if we were going to verify it algebraically, okay, so is this where this is what the graph looks like. Okay, so if we were graphing it on the graphing calculator, the x squared minus 3x minus 7 over 3 minus 2x goes in your first line for your y equals, and this piece goes in your second. Okay, and you'll notice this is the equation for the first one, and this is the x minus 1 is the green line here. Okay, so where they cross, those are where your solutions are. So your solution should be here at negative 0.43 and here at 3.09. Okay, so if it says graphically, use the graphing calculator. If it says algebraically, then we can do what we did in example 1 and just solve it. So our equation is this. Okay, and we always want to try to get rid of a denominator, so that we can solve this easier. So we're going to multiply the tops. Whoops, sorry, that's not a 3x. A 3 minus 2x, we're going to multiply each of the tops by. Okay, so these will cross off because there's one in the top and the bottom. So you'd be left with x squared minus 3x minus 7. And these guys are going to FOIL together. Okay, so it'll be this to this. First to second, second to first, second to second. So we'll have x times 3 is 3x, and x times a minus 2x is a minus 2x squared. And then we'll have minus 1 times 3 is minus 3, and minus 1 times minus 2x is positive 2x. Okay, now the key is to get everybody over on one side and see if we can factor it. Okay, so I'm going to, well, let's move these. They would have to be the same to cross off. One's a minus, and there's a 2x here. So these are like 3x plus 2x. So we're actually going to subtract 5x over. Okay, so subtract 5x and add a 3 over here. And then add a 2x squared onto this side. Okay, so I moved everybody together. So a 2x squared plus an x squared is a 3x squared. A minus 3x minus 5x is minus 8x. And minus 1 plus 3 is 2. Oh, sorry, this... Do I have one thing wrong? This guy is not a minus 1. I can't read my own writing. He's a minus 7 plus 3. So that makes a negative 4. And that should be right now. Okay, to save some time on our video, we would try to do decomp on this, like what multiplies to 12 adds to 8, but we'll find out that we can't do decomp because there's nothing that works out. So what happens when you can't just factor it normally? What do we always have to use? Quadratic formula. And we should have known that we needed quadratic formula because when I showed you, when I showed you these points, they were 3.09 and they were like 0.4, negative 0.43. They're decimal amounts. If it was factoring, it would have worked out to whole numbers. Okay, but they didn't work out to whole numbers. So our clue to save time should be, I'm probably not going to be able to factor this. I'm going to have to use quadratic formula. Okay, so quadratic formula, remember, this is your A, this is your B, this is your C, and your quadratic formula is this. Okay, so we'd plug in our A value in the A spot.